Hi, I'm Chad Galise, Program Manager for Nonlinear Measurements and Modeling at Keysight. And today we're going to talk a little bit about our nonlinear capabilities, including the X parameters. So this system now has an NVNA, and it can directly control Mori tuners for passive. It has active sources that we can use for loads as well, controlled DC supplies, all for devices here, a transistor, a bare transistor as an example that we want to model. So if we look in the code over here, under utilities, we have the capability to control external instruments. As an example, this DC supply. So we pick the DC supply, it has multiple channels inside, and we're able to graphically just click to enable it, select a module, select the type of source, whether it's voltage or current controlled, and then set the current limits on it, and it'll automatically set the right programming commands to be able to control that. We can also set up the tuner directly that way, the characterization files, and everything will be automated. One other nice feature is under the calibration, we have a calibration plane manager, because some of this becomes more complicated where we have tuners and they're calibrated at a certain plane. Then we have our VNA calibration maybe at another plane. And so this way we graphically understand that, and we can easily select multi-tiered de-embedding. So once it's all set up, we use our arbitrary load control application that applies load pull to an extraction of an X parameter model. So it reads all that data into the application, then the application can adjust those values, and it'll feed it back into the network analyzer for the final model extraction. So you set up the bias, it can set up the sequencing, you can do measurements of the DC IV curves, you then select the DC bias conditions that you're interested in. Then you can select the mode, whether you want purely active load pull, passive load pull using a tuner, or a hybrid combination of those two. Then you select your bias conditions, your RF, your frequencies, stimulus. Then you can select your load conditions of what your grid is that you would like. It can be done in a rectilinear space. It could be done in a magnitude and phase space, or it could be done in just pure A2 space. Then we make the measurement, and then we can look at some of the values such as delivered power or efficiency. So here are the contours for maximum power delivered. We can look at the impedance, the delivered power, the gain, and the efficiency. After that, we can look at some of the display functions like P in, P out, gain, drain current as an example. And we can look at that over all the various conditions that we measured. So here's all the different loading conditions. And we can vary that and see how all these different metrics change. Additionally, we can look in time domain, see the waveforms, the voltage and currents. We can also look at the dynamic load lines here in this lower quadrant. Once we like that, we can additionally look at the magnitude and phase of the fundamentals and the harmonics that are measured. In this case, the phase of the fundamental at the output has been advanced 76 degrees from the input wave. Once all that is done correctly, then we move to extract model, and it'll automatically extract an X parameter model under those sets of conditions. Then that model can be brought into ADS and used for simulation to optimize design and validation of the device.